In this tutorial today, I'm going to show you how I made this cool point cloud system using UV unwrapping and kind of my own home-baked sprinkle system in TouchDesigner. All right, thank you everybody for watching today. I really enjoyed making this tutorial. If you want to see that Genoma tutorial I mentioned in this, and you can find that link down below. Also, if you like this tutorial and you want to see more like it, be sure to like and subscribe down below as well to see my future tutorials. I've been doing about one a month lately, and I'm going to try and stick to that. If you want access to my project files for this and all of my tutorials as well as my tools, I have like a specialized blob tracker tool that I think is pretty cool that a lot of people have been using. You can find that on my Patreon page. My Patreon supporters get access to all those things. Also, just to know, I am a freelancer and do interactive installations and generative art. So if you have any projects where you want some extra help, I have my contact information below, and I'd be happy to chat with you on how I might be able to help you with your projects. Thanks so much. Let's get started. First, I want to show the problem we're solving here. So a lot of times when I'm doing particle simulation point clouds that are based on some sort of geometry, whether that's an imported model or if it's even a built-in piece of geometry that I've got in the system, so like a torus or something like that. So normally, if I want to have like particles spread across the surface of something, I can bring in that geometry and use a sprinkle. But you'll notice in this model in particular, you'll see, the sprinkle is not very even. It's not very spread out like nicely. And that's because this is using a per primitive calculation where it's, making my 10,000 different particle points that are all spread out across this. But they're not evenly spread because there's more geometry kind of around these curved points, like around this nose hole. And so there's more points getting placed here than, say out here where these pieces of geometry are a lot larger and spread out. So I want to have a nice smooth set of points spread across the entire thing. If I do a sprinkle across the torus, that's going to be, let me try to home that. It's going to be a little better, but you'll notice, maybe you can notice that it seems to be a little more like concentrated here inside than on the outside where the pieces of geometry are actually larger, right? So we've got smaller pieces of geometry on the inside, larger on the outside. So it doesn't spread it as evenly as I wanted. So this is going to be the way to get around this. And this, I will say that I learned part of this method from watching Genoma's tutorial that you can find here. I'll link this in the notes below, but it's a pretty great little tutorial. He talks about tangential movement across the surface and how to do it with tops and kind of like the current version of TouchDesigner. In the next version of TouchDesigner with pops, I think there's going to be more efficient ways to do this, and I'm excited to see the different ways that show up to do tangential movement across the surface of geometry. Also, I will say too, so I have these 3D models that I brought in here, and all except for this one, and I'll discuss why I brought this one in a minute. I made these with a text to 3D model called Rodin that you can find at hyper3d.ai. It's a pretty nice, simple way that you can just type in a text prompt and get a piece of geometry out. Especially if you just to do this tutorial, you can go in and put in some text prompt to make a piece of geometry that you can use. Okay, so let's get to my method. So the first thing I'm going to do here, now you'll notice I brought in the geometry and brought it in as pops. I'm currently using the experimental version, the 2025 30280 version of TouchDesigner. It doesn't really make that much of a difference here. I mean, as pops become more popular, we'll see them replacing SOPs in a lot of places. And in this tutorial, you can almost go one for one for SOPs. And I'll try to point out if there's any differences. But if you brought these in as SOPs, this is going to be pretty much the same process if you're on the current version of TouchDesigner when I'm talking about this, when I release this tutorial. Okay, so first thing I'm going to do is I'm just going to create a null just to make this easy to switch between some of these in the future. And I'm going to call this my model. And I'm going to go ahead and throw this into a little render network here. So let's click out, drag, and hit tab and hit geometry. This is the most asked question I get from people watching my tutorials, so I'm going to reiterate how I do this. So I drag out from the geometry, either the stop or the pop geometry. And while I'm holding this, I hit tab to open this and then hit geo. And that will create a geo with the input already added onto it, and gets rid of the torus by default that's in here normally. And anyway, that's the way I do that. So if you say I can't connect my model to my geometry, you need to drag out from here, hit tab while you're holding it, and select your geometry. Okay, next I'm going to add a material. Now for this technique, you're going to either need to use a Fong or a PBR material. Doesn't really matter too much. And then I'm going to add a camera, which we won't change anything on either, and then a render. Okay, inside my Fong, I'm going to go to the Advanced tab, and then we come to the very bottom here to the color buffer. And so by default, it'll be set to full shading. And so this is saying for my render output, I want to get the full, just normal color shading. Let me first add this material so we can start seeing something. Oh, actually, stand by. We're going to take one step back because, for example, the reason I'm going to go back is this geometry is massive. So this particular skull is like 800 by 600 by 700. I want it all to kind of be in a nice little 1x1 box. So what's nice, this is going to be a pop specific type thing here, but I'm going to use a normalize. There is a way to do this with the stop box operator. But I'm not gonna show that right now. You can look it up if you need to, but pops are the future. So I'm gonna kind of stick with this for this part, just with pops. So I want to bring this down into a 1x1 box. You'll see it. I added this normalized pop, which brought all my sizes down to 1x1x1, but it stretched it out all funky. So I want to do this aspect correct, which is great. And then because I know in the future I'm going to have a camera sort of pointed at the center of this thing, and I want that to, when I switch out the geometry, I want it to be pointing right in the middle of this. I want to kind of center this into the point of 0.5, 0.5, 0.5. So you'll see it's kind of close, but it's moved over to the left side because it's normalizing it to go from 0 right now for once it fixed that aspect ratio. So I'm going to also add a transform here. Oops, my transform pop. And I'm going to use the Align tab and say I want to align based on a reference input. Now, what reference input? I don't have one right now. So that's what this second input is. I'm going to create an input point, and this is simply a single point in 3D space. That is at 0.5, 0.5, 0.5. And you'll see the tiny, maybe probably not on YouTube, seeing that compressor. There's a tiny little dot floating at 0.5, 0.5, 0.5. And that's what this is going to center around after I select reference input for all these, and they're selected the center. So now my geometry is in the center. Now if I swap out anything else into this, it'll also be centered around 0.5, 0.5, 0.5. And that's just going to make things kind of easier throughout. Okay, it's going back to my render network here. Sorry about that little detour, but it was important. You'll see now I can see my geometry here. Inside of my material under advanced, it's full shading. I don't have a light, so that way it's not lit up right now. So that's where you're not seeing my actual material. But I don't need to add a light because I'm actually going to switch this to be a world space positions. So what world space position means, if you don't understand that immediately, is that based on the point of where that piece of texture is in the space, it's going to give me the XYZ position in the values of the color. So the red is going to equal X, the green is going to equal to Y, and the blue is going to equal to Z. And so with knowing that, I mean, you can kind of see what I'm talking about here. So the Z value is blue, so these are more blue this way. Green value is the height, so you see it gets greener as it goes up. And the X value as you go left to right here is red. So every single point here is translated into a XYZ position. And so so that's kind of cool. And I think in Genoma's tutorial, he kind of stays in this sort of mode where, I could use this information, and I'm going to put it in a null. And if I right click, I hit activate and right click, and I say view as points, you'll see, it is giving me sort of 3D positions, but you'll notice it's only the front, only from what I can see with my camera view. And for my point cloud simulation, I want it to be a full wrapped around particle simulation. I wanted to have the back of this. And I'll also get into why these little sort of echoes are showing up here too. But let's go back first to getting that full wraparound. So the way I'm going to get that wraparound is in my render. I'm going to go to the render mode, and instead of the 2D render, I'm actually going to do this UV unwrap. And what that's doing is it's taking all the different textures that are in this model, and it's unwrapping them to be flat and uh, adding this color that we've embedded in with the world position. So now, if we scroll around this, you'll see we have that full skeleton front to back, and it's also, if you can see, I mean, it's like a pretty regular grid of pixels, um, and it only looks bunched up in those tight points because there's some stacking up on top of each other. Okay, so we're already getting pretty close to what we want to get here as far as like our particle stuff. But let me go through a couple things. First of all, let's fix these little problems here. So these little shadows are happening because at the edges of this, they're getting anti-aliased. So they're getting blurred a little bit with the alpha, so it's blending it towards 0. We don't want that. So in the render, I'm going to go to my anti-alias, hit off. So that'll get rid of those little shadows, which is great. And then also, if I look here, I mean, if you can see, this grid is looking pretty regular, and there's kind of particles stacked up on top of each other a little bit. And I just need to, I'm going to increase my pixel precision here by going from 8-bit up to 32-bit, and you'll see now I have a little more smoothed out, even more dense particles everywhere here. Okay, so what can we use this for? I mean, there's really a lot. And let's talk about how many points we're using here. So if I middle click on my render, I'm at almost 1,000,000 points, 921,000 points, and I can just change how many points, how many particles I'm doing here just by changing my resolution of my render. So let's go 256 by 256. And that gives me a pretty spread out grid. But I can also go up, to 3,000 and have a nice, really dense system. And I'm going to go through why you might want to use either of those here in a minute. But so that's one. As a small addition too, I also want to show, like, sometimes for certain particle simulations, you're also going to want the normal data from this sculpture. And Genoa also uses that in his tool. So let me bring this down a little bit just so my system is not going so slow. But to get the normal information in a similar package here, I can just go back to my material, go back to that advanced tab, and I can add another buffer. So if I add one, instead of full shading, I'm going to go to world space normal. And then in order to access that, I need to use a render select. I'm going to use this render as my reference for what render select I'm selecting from. And then in the parameters, I'm going to select the index buffer for the buffer of index 1. Still not there yet, because if I look at the error, there's no color buffer for the specified index. What that's saying is that inside my render top, I go back to the render top's advanced tab. And then in the number of color buffers, I need to say I want 2. Okay. And this is, I mean, I feel like this is maybe why people don't use this very often, because everything's so spread out between the material, the render select. But this is super useful information. And I think especially as we get towards using pops more, this is going to be even more useful. So if I render this as points by A and V, you'll see that nice circle. So if you don't understand what normals are, this is a great way to illustrate it, is that the normals are saying what direction in XYZ space. So instead of these are the red, green, blue values representing the XYZ positions, these are red, green, blue values representing a vector with a length of one length, and what direction that vector is pointing towards, or what direction that piece of the model is pointing. And so this should be a complete circle, or just about, if I have a model that has directions and that has faces facing in every direction. That's why you get a circle when you render a normal information as points. Okay, so let's see, what else can we add here? One thing you'll notice, I mean, you see the arrows kind of continually moving through this. So these are rendering every frame, and I don't really need that. Like, I'm not moving this model right now. and I don't need to render it every frame. I can just lock it, and you'll see then these freeze. I'm not like using any extra, you know, any extra cook time to render this every frame. So um, I might come back and unlock this when I switch between models because I do want that to render separately. And you know, if you have some system you're building with this and you want it to dynamically like render and unrender, you could lock and unlock this. Or maybe there's another method. If you know one, definitely go in the comments and tell me, and I'll make sure to update this at some point with that. Okay, so what do we do now? So we've got our little conversion from a model to point cloud with a nice smooth surface. Um, let's talk about a little bit of a detour here, but to get a non-regular distribution. So I mean, with the sprinkle top, you get a more random distribution. With this one, you see it's almost just a perfect grid going around it, which might be what you want, but it might not be. This is a great spot where you could use, instead of just this, you can also sample from this to get your different points. So I'm going to use a noise top. And because I'm going to be sampling from this, all I need is X and Y values, or U and V values, or red and green values. So I'm going to go in my noise, turn off monochrome. I'm going to go to my common tab and change the pixel format to be 32-bit RG, because I want them to be very precise values. Very small values are great for this. And then I'm going to bring down my period really small. I'm not going to do random because I'll show you a cool effect where we can actually animate this here in a minute. So these are going to be my red and green values that I'm sampling from this. And I do that sampling with a remap. So bring in a remap. And the remap is essentially saying, with this input, I want you to use these positions to look up the values at, each of these individual y points. So like the R and G values, so it uses that to look up points here. In my remap, I'm going to say I want my resolution of my remap to be based on the UV image. And then I also, if you notice, it's only red and green, but needs to be full XYZ positions. In fact, let me show you what this looks like, because you might run into this. So if I hit A and B to render this as points, you'll see I'm not getting any depth, just the X and Y values. So if I change that to be 32-bit float RGBA, then we're getting all those values. And you'll notice here again, we're getting some of this sort of like, shadowing, echoing back to zero. That means that at some point we're smoothing something, or we're blurring something somewhere. And so that normally in this situation is going to be in the common tab. The input smoothness is set as interpolate pixels. Now I have mine set by default, so you'll see that I got rid of it. I have mine set by default in my preferences. Oh, it came on my other screen. In my preferences under DATs, under tops, I have my default as nearest pixel, but for some reason, every once in a while, I don't know if it's the new experimental version, but it won't set it to that by default on some of these. So, okay, so if I take a look at this, and I look closer, okay, actually, this is still looking fairly regular. So what can we change to like fix that? So we still have 32-bit floats here. So it's not that, but I think what it is in this situation is this is just a 256 by 256 resolution input image. So this is where rendering it really large would actually help me out, because even though this is going to be large, let's do 3000 by 3000. Once I lock it, I mean, I'm just sampling from this now. So it's not cooking every frame with that, but now you'll see it's a lot smoother, sort of spread out distribution of particles. Cool. So I really like that. Let's take that as our output for now. Okay. And when I mean output, so let's position. Let's call this, give this goal name of position. And then because what I'm going to do in the end here is I'm going to make a new rendering network to render these particles in some final form. I want to put these in their own container. So I'm going to select just this middle section here with my render network, and I'm going to right click and hit collapse selected. And so I'm going to call this model to particles. And you'll see I've got my nice little sampling of XYZ positions there. Okay, cool. I forgot. I wanted to show one more kind of cool effect with this. I didn't animate that noise, and I want to show you what you can do with that because, um, yeah, let's get to that. Oops. Okay. So, like I said, I have a noise here that's still simplex 3D. It's not fully random, and I could just do random, and it'll give me a nice distribution. But if I go to simplex 3D or 4D, whatever you're feeling, and then I bring my period way down, so it doesn't have to be that far down, but I guess we'll play with this period actually because it's going to make a difference of what we want. And then if I animate this noise, so do abs time of seconds, and I needed to make this a very very small change. Um, so I'm going to divide it by 500. So I have very slow movement happening now. But if you'll see, what's happening now is I'm slowly moving these pixels of where they're sampling across this image. So I'm actually getting a tangential movement across the surface of this kind of for free without doing anything too fancy as far as calculation goes. I'm not having to do any like dot products or cross products to like get what the perpendicular or the tangent like uh, direction is on this. I'm just moving across the surface by using this sampling. So I think it's a kind of fun way to get this effect. And so now if I go in the noise and I pop up my period, I can start to see more interesting things. Like if I make it, up into a couple integers, like you'll get this tangential movement with sort of like shapes and like kind of coherent movement across it. But I'm going to leave it low for now. So I get this nice kind of more random particle sampling. Um, okay. I'm going to go back up a level and back to this position. Okay. So what should we do now? So I want to show also this method of using a mat to transition particles particle simulations between two different effects, essentially. So I'm going to start with this position, and then I'm also going to make a noise, kind of a noise cloud. So if you follow a lot of different particle cloud simulations, you'll see this. If particle cloud tutorials, you'll see this. So if I A and V on this, and then let's set some parameters. So I'm viewing it as the particles right now. If I turn off monochrome, and then I'm going to go in my output, I don't want to use the input at all. So I'm just going to use just the noise. And what's great about this already is because since I centered this around that 0.5 XYZ point, if I make my amplitude 0.5 and offset it by 0.5, this offset means it's also going to be these points are going to be centered around that 0.5 position. Also, it's important here, 32-bit float, just for smoothness. Also, so your points go out across. They go up past one or past zero, they'll still show up. Okay, and then so I've got my point cloud. Let's animate this to make it a little more interesting. Apps time in seconds. Over this one, we can be a little smaller. Let's do like 66. Okay, so we have some nice movement happening in these particles now. Okay, so now I want to have some transitions between these two point cloud models. And the way to do this, I think I learned this method from supermarket style, this idea of using mats as your sort of slider between two different particle simulations. So let me show you what that looks like. So if I go to the mat top, so the mat top will take two inputs, 1 and 2. And normally when you think about a mat, I mean, a lot of times traditionally a mat is used to say like I have two images and I want to decide where one image is transparent to the other. But in a point cloud system, that same idea can be used to say like I have two sets of XYZ points, and that mat value is essentially just a slider of how much you want to be taking the input for that XYZ point from model 1 or model 2. So let's take a look at what that looks like. So I'm going to use, well, let's first illustrate it with a simple ramp. And this actually might not show us too much because these are randomly sort of situated. Let's go straight to the real illustration of what I want to get to. I won't bore you with that stuff. So if I bring this into a threshold, right? So again, this is XYZ data coming in. and I have a threshold, and the threshold is saying, when I'm less than or above this threshold, that's what I want to control. Um, and in our simulation, let's say I want to transition from the top to the bottom. I want to use the green channel for my threshold. So now as I move the threshold up and down, it'll have those pixels go from black to white, based on their green value, right? So let's pop this in here and see what that looks like just to start. So if I take this and, oh, I forgot one thing. So in the mat, I've done this many times and I always forget. But in the mat, I want to say the thing I want the mat channel to be looking at from this third input, it's not the alpha. I want it to use the red channel, because if I make this, and then I'm going to make this like a 32-bit mono. It just needs to be black and white. Um, Okay, and let's take this out to a null. This is not any longer representing what we're looking at. This one, oops, not that. Hit A and B to show my particle system. And then I'm gonna right click view, throw it up here in the corner. Okay, so now if I change my threshold, you'll see I'm transitioning between the two of them. And you'll notice it's a very like harsh transition over. And so there's a couple things I want to do here. First of all, if you remember, some of these particles, some of the source is actually has zero alpha. Like if I normalize all my views, like some of these particles, I don't actually want to render out because they're at a 0, 0 position with with an alpha of 0. And so I want my noise positions to kind of respect that as well. So inside my output for my noise, I'm going to go in the alpha and say I want that to be the same as the input. So now, let's see, as I transition across, yeah, when I get to 0, like all the skull ones kind of like disappear. Okay. But now to make this smoother. So this is just, the threshold right now is just straight up zeros and ones, black and white. But if I take the soften, I bring it all the way up to 1. Now I'm going to have this nice transition as I go across my threshold. And you'll see, obviously, I'm at threshold 0 and it's only halfway transition. I go up to 1 and it's all the way transition there, I guess, or maybe close. It might not quite be all the way. But let's animate this a little bit so it's automatically working. We can change things to make it look better as it's moving around. So I'm going to use an LFO to change this threshold number. And I'm going to slow it way down. And then, I want it to go down past 0 because it's not transitioning all the way. So let's offset it a little lower. We can make sure it's going as far as we want. So I'm going to bring the amplitude up so it goes further out. Cool. So yeah, so if you can imagine, I'm essentially taking each of these points. So if I take them back to this, right? Like this is all I'm doing is I'm using a map to say, based on what the value is here, is how I want you to transition between this for the white value. When it's white, I want you to be this value. When it's black, I want you to be this value. And this is how far between those values I want you to be. So, okay, so now let's do, let's call this points, and let's do a quick render to get like a final output out of this. So let's create a pretty standard instancing network here now. So we'll just do it with points. So I'm going to add a SOP point. I could also actually, I could do this with pops as well. So point, or even it's going to show some SOPs or pops. I'm going to go to pops because that's the new thing. So let's go SOP to pop, or sorry, top to pop. And then what's cool with these is that it automatically, like, it's bringing in just this data, but pops are smart enough to know, like, hey, I might actually want, instead of using those as the color, I want to use the position and active. So it's going to use that alpha as whether I want these points to actually be activated or not. So you'll see, like, even though there's 65,000 points in memory allocated, I'm only actually using 41,000 of those because it's saying, like, anything that's alpha, I don't actually want to make a point for. Okay, so, and then I can actually bring these straight into my geo. And then I'm actually not even making an instancing network anymore. It's just going straight from that point data into a geometry. And then I'm going to add a camera, and then let's do some material. I'll do, um, let's see, let's do point spray to see if that'll work actually. And can I change the scale size? Yeah, I can still do that. Okay. And then I'm going to add a render. And then let's make our render vertical. And let's line this up a little nicer. Let's make our camera a similar shape to what our actual render looks like. So that way it's actually a decent like simulation of what we're going to get. Let's do like that sort of low look. And let's put that into an out. And I'm going to right click and hit view on that now. Let's get rid of this guy. Cool. Let's say maybe I want to like spin this thing around. So again, let's have a speed chopped controller rotation. This is something I've been doing more of lately. So where I can just, adjust how fast or slow I want something to be there. I'm going to right click and add that, go to rotate around the Y. And then I want my pivot position to be 0.5 for my center position, because I know everything's going to be centered there. And then I come back to my speed. Let's say with the rotation, you got to do it higher, right, to really see what you're doing. Let's do 10. Maybe a little faster than I want. Let's do 8. Okay. So now I have a nice little rotating sculpture. That's cool particles, the transition happening. I could slow down how fast it's going by this frequency. Let's do like, one every 15 seconds. And then, now I can like come in and change what model I want. So, okay, so I brought in my flower. Oh, but it didn't update. What happened? It's because if you remember, I locked this render. I'm going to unlock it. Yes. And then I'm going to lock it again. So that way it's only like creating this world position map for me one time. Now I've got a flower in there instead. Okay, and so another thing you might run into is you might download a cool 3D model from like TurboSquid or from something you made yourself in Blender, and maybe you run into this problem. So this is what this wild boar is going to be here. So I'm going to bring in my wild boar and then go back and unlock. What happened? There's nothing there. Like I'm seeing something here, but it's not giving me any positions. What happened? So this is happening actually because this wild boar doesn't have any texture locations on it. So it's just got a point information and normal information, where like my skull has point information, normal information, and texture information. So if I bring in this wild boar and and this is going to be the same in SOPs as well, so that you need to add a texture map to it. So you'll see I'm already getting something because I am still actually rendering this boar. Yeah, so you see already it's giving me some information that I can then sample with world position. The problem you'll see is that it might not be the best texture mapping, right? So because we're just like saying TouchDesigner, just throw this texture map on with like from the perspective of the Z. You can kind of see it here. Like if I was like, if I can only see from the Z position, then give me those points. It's definitely not as good. And you can play around with inside of this texture map the type of projection you want. So like instead of through the Z axis, if you want it to come from the Y axis, like from on top, you can change that there. Yeah, I think there was probably a better way to do this, and I haven't quite discovered that yet. There might be something around like converting your points positions to like maybe to point to vertex positions, something like that. Like, and we call this text maybe. No, I don't think that's going to be right. Let's double check this. I might delete this. Yeah, that doesn't really work, does it? In fact, I think that's what one of these methods actually does. So anyway, there's probably a way to do it that I haven't figured out yet. But so stay tuned. Or if you know how to do this, definitely hit me in the comments. Share with everybody else on how you would fix this texturing issue. I'm going to go back to some of these other models. These are my Rodin models that I brought in. These come in with a nice texture map, kind of baked in already. Yeah. Also, let's see, what else can we do? Let's add a little color to this. Since we're in pops world here, so let's add our color after we get to the pops, and let's just do like a noise. And my output, I don't want it to be my position, I want it to be my color. See, I'm getting an error. Combine attribute scope, input attribute not found. Oh, it's because I'm saying add. I want to set. So let's see. I want to, instead of noise, I want to put color there. No? What is this wrong? Color should be float 4, not an array. Okay. Let's say we want it to be 4. There we go. Now we have colors, but they look terrible. That's because our amplitude is not full amount. Let's go back to 0.5 offset, 0.5 attribute. That looks a little more like a normal noise distribution. I'm gonna pump up or change my seed, pump up my period so I get kind of like, you know, a couple little gradient colors, but they're going to be based on their positions. So because automatically in pops it uses the position as a lookup for that noise. So if you understand what I'm doing here, in pops I'm saying I want to add noise. I'm gonna the color is kind of the saved name for creating a color in a render. Um, so I replaced the noise name with color here, and it's creating that attribute in this top. So yeah, I think I'll leave it at that. I would definitely love to see people make more cool stuff out of this. So if you have any fun ideas of how to like expand on using this, I've been using these point clouds in a lot of projects lately, and I feel like there's still a lot to get out of. But I hope this helps you with creating some really rad point cloud systems, and we'll just leave it at that.